Hi, this is Mike of 71 Squared and welcome to tutorial 10. A bit of a landmark, we've hit double figures on the tutorials now. Apologies that this tutorial has taken some time to come out. I was hoping to get these things out close together than they have been, but things have been pretty hectic in the family way and in work, unfortunately, my day job. But I have got this far now, so we can get tutorial 10 up and running. What I'm going to cover is what I've talked about on the blog, which is that unfortunately I'm not very good at tracking the changes I'm making between one version of my project and the next. So I have over the last sort of few weeks got carried away and sort of stormed ahead getting things written, and obviously going back and trying to understand what I've changed and making that available as an incremental build on the tutorials, the tutorial projects that is quite hard. And unfortunately I haven't got the time to really sit down and do it. So what I've decided to do this time is to use my entire sandbox project, what I've been building my little application in, my little game in, and literally just putting that out there, sharing all the code with you. I'll go through as much of the code as I can today to give you an idea of how things have been built and how I've structured things. And then if there is anything that I can't cover today, then we'll cover that in future tutorials. So for example, the collision detection was something that I wanted to cover in this tutorial. Unfortunately, I've not had a chance to add that collision detection code into my project yet. There is collision detection code between the player and the tile map, which I think people would still find useful, but having the player collide with ghosts or being able to shoot a weapon and having that collide with other objects is not something I've got in the code yet. So that will definitely be something that I cover off in later tutorials. So what I'll do is we'll jump straight in and I'll open the project. You'll have to excuse the name. It's called Tutorial 1, which is because this is the project I started way back in Tutorial 1 and I've not renamed it. When you actually do run this, I think it actually calls itself OGL Game, or My Game, there we go, is the name that it's got. But the actual tutorial, the actual project, sorry, is called Tutorial 1. So by now, things are actually getting quite big. We've added a lot of code to the project now. We've really started to build an engine. And as I've been saying all the way through, there are more optimized ways of doing a number of the things that we're doing. We are using classes in places where we could use structures. And we are probably using an object-oriented approach in areas where it probably doesn't fit inside game development. That said, what I really wanted to do with these tutorials was, as I'm going through and learning things around the best way of structuring the program, was to share that in the most simple way that I could find. And that's really what I've done in terms of the projects that we've got here, is I wanted to be able to give you in a simpler way as possible the code, and sometimes object-oriented approach is an easier way of actually understanding what's going on. Later on, I'm going to try and cover off optimizations with the code, things that we can do to speed up what we've got, and that will involve using structures and those kinds of things. So there are more optimized ways of doing what we're doing, but for the moment we're printing things on the screen or rendering things to the screen. We can move things around, and hopefully that's enough for everybody to sort of get up and running and be able to then start to tweak it for their own needs. So running through, what I've done here is I've tried not to change the API as much as I can. There are some changes that I've made. One of the most obvious changes that I've made is to the image class, which if I open up the game engine, the graphics engine folder here, or group, and I open up image, if we take a look at the header, which is the most obvious place to check out the changes, what you will see is that inside the initializers, where you would normally pass in a UI image, you're actually now passing in an NS string. The reason for that is that I've introduced a name, so an image name, which is logged against the image, and that is being used inside a resource manager that I've created. So I've created this object called resource manager, which looks after caching texture 2D objects. So as you'll remember, an image class actually is a wrapper around a texture 2D instance, which is what is loaded into GL and becomes a GL texture. So what I've done is, to try and sort of optimize things a little bit, is I've created this resource manager here, which we'll have a look at in a moment. And what that does is it checks to see whether the texture or the image that you're asking to create, whether a texture 2D image has already been, or instance, sorry, has already been created with that image name. If it has, it will just give you a reference back to that, rather than going through the process of loading another texture 2D image. So to do that, I needed to give each image a unique key, and the key that I'm giving it is their image name. Okay, so now when you pass into the initializer, you're actually passing in an NS string, and it is going away and creating the UI image and the texture 2D for you. You don't have to pass in a UI image that it is then going to process. So that's quite a change from the old image class, and that will obviously break your programs if you're using that. So very important that I highlighted that to you. You'll also see that I've started to try and format the project a little more neatly, just for my own reasons more than anything else. So I have started to comment things and lay things out a little differently. I've started to try and introduce a naming convention where any property which is being sent in, or any value which is being sent into a selector or a method, is actually is called a something, like a scale or a filter or a image. Just again to try, I was using the in the past, I've switched to a, no other reason than I'm just sort of really trying to find my own style in Objective-C, and trying to follow the Apple guidelines in Objective-C as well, about how to lay things out, how to do naming conventions and so on. So hopefully the extra comments and the laying things out like that will help. Not had a chance to do all the classes yet, but I'm going through them as I touch them to reformat them. So if we have a look inside the .m file for the image class, we can have a look in here, and if we drop down, we'll see that we are taking this NS string now for these initializers. And if we look at the implementation file here, you'll see that I've got two things that I'm grabbing hold of. I'm grabbing hold of this thing called a director, which we'll cover in a moment, and basically the director is the shared game state. So we had a class in a previous tutorial called shared game state, where you could log things like the currently bound texture. I've just changed the name basically to director, because it is going to allow us later on, as you see, when we have different scenes in our game, to direct us to which scene we're actually meant to be rendering and so on. And also grab another reference to Resource Manager, which again is a singleton class, so there's only ever one instance of it. We go and grab the shared Resource Manager instance, and we then store that in Resource Manager. So you'll see that when we then create the texture inside our image, I'm asking the Resource Manager to go and get texture with name, and it's feeding in the image name. And what we'll see the Resource Manager do in a moment is that it goes away, checks to see whether it's already got a texture loaded called image name, and if it has, it will pass back a reference to that. Otherwise, it will create a new texture with that image name, add it to the cache, and pass back a reference to that newly created texture 2D. Now, as it's passing back a reference, we're responsible for retaining that, because we don't want the Resource Manager to be responsible for it. We want our classes that are asking for a reference to be responsible for retaining it, so that when this image instance is destroyed, it will release the texture retain count that it's got against whatever the image name is that we've actually used in this image. Okay. There are a few other changes internally in here as well. I've done things like, if I scroll down to, here we go, to calculate texture coordinates at offset. Very simple check really. What I'm doing is I've wrapped up the calculation of the texture coordinates inside an if statement. And what this if statement does is it takes the offset into our texture where we want to start to get or calculate our texture coordinates from, and checks to see whether that's the same as the last time we asked for a texture coordinates from this image. If it's the same, then it means that we've already calculated the texture coordinates once already. There is no need to now go and calculate the texture coordinates again. So the check basically says, well, if the offset point we're asking for is not equal to the offset point that we've done last time, then it will run through here, calculate the texture coordinates again, and handle the flip horizontally and vertically. If they are the same, then it'll just skip all of that, and it will just drop to the end and finish. So what we are doing is, for images where we are always getting the same texture from inside our image, it's just speeding it up. We're just getting rid of all of that extra processing that's unnecessary. So that was one of the changes that I've made inside the image class as well. Apart from that, you should find that the image class is pretty much identical to what you've already got, including how it's actually doing its rendering and so on. So there are no other real changes to the image class apart from the biggest one, which is that we're changing these initializers to not take a UI image but to take an NS string. Okay, so we talked about this resource manager, so we'll have a quick look at the resource manager, which I've got up here in this group called Singleton Managers. You'll see I've got a few things in here. I've got a director, I've got a resource manager, so the director is the shared game state we had before. I've got a resource manager, which we're going to look at in a moment. I've got the sound manager, which we've covered in a previous tutorial. And I've got render manager in here, which I'm actually going to delete because it's just an empty reference at the moment. As I said, I am looking at and working on creating a render manager which will allow us to batch up geometry and textures, so that we're batching up those calls so we can get away with fewer OpenGL API calls basically. For the purposes of the game that I'm writing at the moment, what we're doing now is not causing me a bottleneck, but certainly if we wanted to put more things on the screen, rather than calling the GL draw arrays or GL draw elements separately a number of times, which at the moment image is doing, it's calling one of those per image you want to render, we would really need to batch them up, which will improve efficiency and also improve performance as well. So if we have a look in the header of our resource manager, it's a very simple header. We're just creating an NS mutable dictionary, which is going to be storing our cached textures. And then we have three selectors or methods. The first one returns a texture2D image pointer, texture2D pointer, and into this get texture with name selector we pass in the string, which is the texture name. Okay, so that's going to be the name of the image we want to load. We also have a release texture with name, so that we can actually release a texture if we don't want it anymore to save memory, and we can also ask for all of the textures to be released. Okay, so it's actually a pretty straightforward class. Now, something else that's worth mentioning at this point is this definition up here, this class definition, okay, which is like a forward declaration. What the @class function does, or what the @class allows you to do, is to say there is a class called texture2D. I'm not importing it in here, but just be aware that there is a class called texture2D, it does exist, and I may be using it later. And that means that inside the header file here, I can reference texture2D without the compiler giving me a warning. So really, it's just saying to the compiler, yes, there is a class called texture2D, and we'll be importing it to get all of the details of it later on. Now, I've done that because as the project has got bigger, and I've had more and more imports in the header files of these, there's ended up being circular references to different classes, and it's all got a bit complicated at times. And doing a bit of research and having a bit of trial and error, it does seem that a clean way of approaching this issue is if you're in a header file and you just want to declare the fact that texture2D is something that does exist and you're going to be returning either a reference to it, something like that, you do the @class declaration. Okay, the actual import of texture2D is done in the .m file. Okay, so inside the .m file, where you're actually going to want to access that class, you're not just referencing it, you're going to access either instance variables inside it, or you're going to allocate new instances of it. That's where you do the import. If you just want to reference it in a header file like this, then you can just do the forward declaration and use the @class function, or the @class declaration itself. So that's what I've done. I've not done it everywhere, but certainly in the newer areas that I'm writing, I am actually putting that in so that we can cover off the fact that we want to have the import in the .m file as opposed to having the import inside the texture2D file. Okay, so what we'll do then is we'll have a look inside the .m file now. And again, it's not a big class. It's actually a fairly small class because it's fairly simple what we're trying to do here. You'll see I'm actually bringing in my import for Texture2D inside the .m file, because in here I am going to be using the Texture2D and creating instances of it. I'm also bringing in the synthesize singleton macro, which is something that allows us to turn a class into a singleton really easily. And what we do is, I must admit, I think I've mentioned this in a previous tutorial where I got this from, so that I can give credit for the creator of Synthesize Singleton. If not, what I'll do is I'll make sure there's a link up on his webpage, or to his webpage on the blog entry, just so you can see who actually created it. But all we do at the top of our .m file inside the implementation is we just say synthesize singleton for class and give it the class name. And that has now turned this into a singleton class. So it's got the class method to be able to grab hold of the singleton instance, etc. Saves us just putting all that extra code in, and it makes it really easy to turn this into a singleton class. I've then got my dealloc routine, and again this is another formatting change. I've now put my deallocation routine at the top of my classes so I can easily check to make sure I'm deallocating everything I should be. I was finding at the bottom of the class it was a bit hidden away and I was ignoring it and not really tidying up things as much as I should. So I've stuck it at the top here to try and make it a bit more obvious what I should be cleaning up. Inside the initialize routine, I take the cached textures NS dictionary entry and I actually allocate that, and what I do is I allocate it with a capacity of 10. Okay, so in other words, rather than every single time I add something to the dictionary it has to extend the size of the dictionary, which can take time, I give it an initial size of 10, which could be changed if you knew you were going to have many more images than that, and it just saves a little bit of time and gives us a bit of performance, because we're not having to extend the dictionary every single time we add a brand new image to it. And then we retain it because we want to keep a copy of this ourselves, and then we'll release it later on. Then we have this get texture with name method, which takes our texture name, and what we do is we create a cached texture object, okay, of type texture2D, and we do a quick check. We ask the cached textures dictionary to see if there's an object for the key texture name. So we're using the name as the key inside this NS dictionary here. If there isn't, then what it does is it puts out an info message, an NS log, and what I've done is I've wrapped this inside an if statement. So as we'll see later on, inside my common folder I've gone and defined a debug flag, which if it's set means that the debug information will come out. If it's switched off you won't see it. It probably would be better to put this as a compiler definition, so doing an if def, so that if it's set the command is entered, if it's not then the compiler completely skips it and it doesn't even get the code generated. But for the moment I've got it as an if statement. If there is a texture there, it means that we have found one, which would be the message here. So what we do is we return that texture. So there's now a reference handed back to the texture that we already had inside our NS dictionary. If there wasn't a texture, then again we could put a message out saying there wasn't, and we go and create a brand new texture using Texture2D, and what we do is we give it the name here, okay? And we're creating the UI image that we were creating in the image class before, we're now creating inside the resource manager. Now one thing to note here is that I have got this filter to GL nearest, and you'll remember that before we could actually define inside our image whether we wanted a GL nearest or a GL linear for the filtering. At the moment I've only got this hard coded to GL nearest because that's the one I was using most often, but it wouldn't be hard to change this method so that you could actually add in the filter type up here that you wanted to use when you created that particular image. And then what we do is once we've actually gone and created that object, we add it to our NS dictionary, and then we return that and auto release it. So what we do is return it, which is why we're doing a retain inside the image class, because we're going to auto release this object, and if we auto release it without doing a retain the other end, it will vanish and the image class will crash because there won't be a reference to it anymore. So that's the get texture with name function. We've then got the release texture with name, which pretty much does the same thing. It checks to see whether we can find a texture with the key that we've passed in. If there is, then a cache texture with the key was found, and so we release it. So what we do is we just remove it from the cache, and that means it's not there anymore. The retain, which was being held by the resource manager, will be released, and as any other images that also have a retain on that particular texture are released, eventually it will get scrubbed from memory when nothing else is retaining it. The retain count reaches 0. If we can't find it, then what we do is we put out an info message if debug was on to say can't find that, so we couldn't release it. And then releasing all the textures is pretty straightforward. We just go and say remove all objects from our NS dictionary. So it's very simple. I'm sure it could be extended later on, and it just gives me a little bit more performance, or a little bit more memory performance really, because even if I'm using the same texture but for a different image, because I'm going to do different things with it, I don't really want to have to be holding the same texture in memory more than once. So this is allowing me to hold the texture in memory once, but have it being referenced by many different image files, or image instances, sorry. Okay, so that's the resource manager, and the reason I've gone through that is because obviously that is being referenced from inside the image class, and that's where there have been changes in the image class to make that work. There are other changes I've made to things like the tilemap class. They're all really internal. For example, on the tilemap side of things, none of the APIs changed, but I've just moved to using GL draw arrays inside the tilemap. So as you can see, I've changed the calculation to be calculating using triangles inside here. I was just really playing around. I wanted to see if I could get more performance out of the tilemap by doing it that way. It really doesn't make any difference, to be honest, whether you do it that way or using GL draw elements. Didn't really see any improvement in there at all, but more for my own learning than anything else, and also interesting to see how that would work as well, moving from a GL draw elements to a GL draw arrays. So apart from that, there's nothing else really changed inside the tile map, so that should be exactly as it's been seen and used in other tutorials. And I think that's probably about it. There isn't anything else in here that I've really done. You will have seen on the blog that there were some discussion around improving the performance of the AngleCode font class by using hash tables to store the kerning information. I've not implemented that yet. I think it's a great idea, and there is some example code, not for using hash, but for doing an enhancement to that to speed up the kerning. So definitely worth checking that out. In a later tutorial I will include that change in my code as well, so that the kerning is faster. And for those of you who are not sure what kerning is, in most fonts there are combinations of letters where the spacing is slightly different. So if you imagine the letter W and the letter O next to it, O is actually slightly tucked under the W. That's called kerning, and so based on the pairs of characters that are working together, their spacing may alter, and that's what we introduced with kerning inside the AngleCode font class. Not in this code, but on the blog you'll find information about code that others have used to speed it up. Right, so I think what I'll do is I'll move on to the general structure now in here, because I've got things like title screens, I've got things like menus and different scenes. So what we'll do is we'll sort of really go through the core changes I've made to the structure of my project. So we'll go into the classes group here, and you'll see I've got I've got a new item here called a game controller. So I'm going to start from the app delegate, and then we'll go through and identify what game controller does and what EAGL view does now as well. So inside my app delegate, something that I have done is I've removed the need to use a nib file. Not for any other reason, to be honest, other than I've started to prefer to actually not use the interface builder, but to actually do things in code. I must admit, for some reason I had an absolute mental block with interface builder, and I've really struggled to try and use it effectively, and I'm not quite sure why, but I have. So what I've done is I've started to move away and actually just go back to code, where I actually get the code to do the things that I want it to do. So what I've done is I've made some changes. I removed the nib file from the project, and inside the main, oops, sorry, wrong one, inside the main, which is in here, I've actually gone and changed it so that I'm calling the app delegate myself from inside the main routine. So it knows that OGL game app delegate is the app delegate to call when the game loads. That was being done by the nib file before. Now you need to do it yourself. So you need to put in there the fact that OGL game app delegate is being used. Okay, and then all we're doing inside the application did finish launching is we are creating a new window which is going to have the bounds of the screen. We're saying that it's going to be interaction enabled, so it will handle touch events. We're also saying it's going to be multi-touch enabled, so it will register multiple touch events at the same time. I then create a brand new EAGL view, again using the bounds of the screen, and I retain it because I want to keep hold of a copy of that. And I'll call it GL view. And then this was already in the code before, but I add GL view to window and I make window visible and key, so that's now got the focus. The next piece of code is something that we've had to introduce since 3.0 was released, the SDK and the firmware. If you had previously said glView and then the name of a method inside glView, it wasn't working. I haven't confirmed the reason for that completely, but it does seem to be around the fact that application did finish launching is running on its own thread. So when the app is finished launching, it's not running on the main thread, it's running on its own thread. So you can call that particular method inside here, but that thread dies after we've had application did finish launching. So nothing happens. We don't end up calling anything inside the GL view. But by using this command, where we're asking it to perform a select or run a method on the main thread and give it the method name, that's working fine. So that line is really there to make it compatible with 3.0. When I get to the bottom of it, or if anybody else has the definitive answer as to why that's on there, then I'll let you know. I've actually got an interesting conversation coming up with Apple next Friday. I'm lucky enough to be speaking to the iPhone OS's product manager and also one of their engineers. So depending on how that conversation goes and the relationship I'm building up with these guys for a project that I'm doing, then I may be able to get hold of some information about why that didn't work. And hopefully some great information in general, which obviously I'll share back out through the tutorials and through the projects that I've got on here. So that's App Delegate. We've now got everything running, and App Delegate obviously runs inside our EAGL view. So GL view is just an instance of EAGL view. So if I drop in here, we'll see that the majority of this stuff looks the same. The key thing which I'll point out is that this here, okay, you'll recognise this line that's been in here before. And what this is doing is, because everything is built on top of a core animation layer, and what we're doing up here is we're grabbing the OpenGL, we're grabbing the core animation layer from this class so that we can actually use its context to be where we render our OpenGL. As part of that context, we have to tell it what it's going to be and what type of context it is. So this here, this EAGL rendering API OpenGL ES1, that's basically saying we want to create a canvas or a context, a GL context on which we're going to draw, and it's going to be using the ES1.1 specification. Okay, so that's the standard that comes out when you run the template inside Xcode. It's pointing to 1.1. Interestingly enough, now we've got iPhone 3GS been released, which supports OpenGL ES2. You'll actually see that if you wanted to, you could change this to say 2 and not 1. So if I actually do an escape here, you'll see you've got OpenGL ES1 and you've got OpenGL ES2. So if you want to write using the 1.1 spec, you select 1. If you want your context to support the 2.0 spec, then you use 2. From a compatibility point of view, the 3GS iPhone supports both 1.1 and 2.0. So if you write something in 1.1, then it will still work on a 3GS. If you use 2, the same obviously doesn't apply. So anything that uses a 2.0 context means that it's going to be using OpenGL shader language. It's not a fixed pipeline. It's going to be using the shader language which was introduced in ES 2.0. And that means that the iPhone 3G and the iPhone first generation, they aren't going to work. They won't support that. So if you want the biggest amount of compatibility across all iPhones, then stick with 1. Obviously you're losing out on all the new functionality around shaders and fragment shaders and all the other good things that come with 2.0, but it gives you the widest view of capability. There are ways, which I'm not going to cover in this tutorial today, but there are ways of being able to query the phone and find out what kind of phone it is, which means you could then do a simple check here that says, well, if you're a 3GS, I'm going to create a 2.0 context and we'll use your shader functionality. If you're not, I'm going to use a 1.1 context and we'll use the fixed pipeline functionality. Obviously there's a level of doubling up there because you're going to have to write for both. So for the moment, to be honest, I don't know 2.0 very well, and shader language is something I really haven't got into yet. So I'm sticking with 1.1 until I've got time to really get my head into that stuff and learn it and see what we can do with it. So just thought I'd highlight that in here. And what I'm doing a bit further down is you'll see I'm creating an instance of this thing called Game Controller. Now what Game Controller is it's this object here, which is new in this project, and this is really where, as it says, it's controlling my game. It's where the real guts of defining the game controller and the game scenes is being done. So we'll go through that in a moment. I'm also introducing here these two commands around the accelerometer. So if you notice inside EAGL view, okay, we're actually inheriting from a UI view. And because we're inheriting from a UI view, that means it handles different protocols, or it handles the accelerometer protocols or interface if you're from a Java background. And it means that we can actually grab hold of instances of the UI accelerometer and actually read from it and understand what's going on inside the accelerometer, so we can use that inside our game. So what we're doing in here is we're actually giving it an interval, which is how many times is the accelerometer going to be queried, okay? And we're also setting the delegate, in other words, what class is going to be responsible for acting upon the information that the accelerometer is going to provide to us. And what I'm doing is I'm saying, well, actually my game controller is going to be responsible for that. Because we're going to have different scenes in our game, like a main menu scene, we're going to have the game scene itself, maybe high score scene. Each of them is going to maybe want to have access to accelerometer information. So what we're doing is, because the game controller, as we'll see in a moment, is going to know which scene we're currently running, it will be able to forward on accelerometer information to the scene that is currently active. So we're saying, for the accelerometer data, let game controller get the information from the accelerometer, and it will then feed that on to wherever is necessary. Okay. Now I did see in the blog somebody's commenting that they still saw this in here, this start game timer. I'm not using a timer at the moment. I leave it in there just when I'm playing around and I want to try things out. But at the moment this isn't actually being used. What I'm doing is I'm jumping straight into the main game loop. And as you'll see in here, I'm using the good old game loop that, to be honest, we started out with way back in sort of tutorial 1, 2 times, where we run it and we just keep continually whiz around. We're not doing anything clever. We're not trying to detach the logic update from the rendering update. So in other words, maybe doing more logic passes than render passes. We're just literally saying, run through this and update the logic and then render. And so logic and rendering are fairly well tied together. In future tutorials, I will look at how we can break this up and actually make the logic updates independent of the render updates. The only other thing I've added in here was, again, there were some great blog entries that were talked about, and somebody posted a piece of code for handling FPS, so looking at frames per second within your game. So what I've done here is inside our shared director, okay, which is our shared game state, remember, I've added a variable that can hold the frames per second. So inside the game loop, what it does is, and 4 times a second, so that's what this little if statement here is saying, it's saying 4 times per second, because you don't want it any more than that really, update the frames per second in the director with whatever we've calculated it to be. So that if you wanted to query that and maybe print it to the screen inside a game scene, you could just go and grab that from the director and use it as you want to. Other than that, the actual loop in here is not changed and is the same as you've seen before. I've gone back and I've actually changed the name of render scene and put it back to draw view, because I'm not actually rendering the scene in here. The scene is going to be rendered, as we'll see in a moment, inside some game scene objects that I've created. So I've put this back to the way it came out of the box, which was the draw view command, and so inside my main game loop I'm just saying draw the view, okay? And above it you can actually see that When I update my logic, I'm asking the game controller to update scene and pass in the delta. Again, the reason for that is that the game controller will know which scene is the currently active scene. Okay, and because of that, as will the director, by the way, so because of that, the game controller will then be able to push the update with the delta to the scene that is actually currently running. Okay, so it just means that no matter what game scene I'm running, because there could be many of them, game controller will push the update to whatever scene the director is telling it is active. Okay, I hope that makes sense. I went a bit around the houses on that one, but I hope that makes sense. So inside draw view, what are we doing? This is now really small. We're not doing any sort of physical game rendering in here. All we're doing is we're switching the context, or we're binding the context to the frame buffer in here. We're then going to the game controller, and just as we asked it to do the update for us, we're asking it to render the scene for us. And when that's finished, we then switch the context. So we go and grab the view render buffer. Okay, that's where we're binding it to. That's basically the color attachment that we've rendered to. So in memory, we've gone and rendered our images to this context, this location, but it's not on the screen yet. So what we do is we present that buffer to the context we're using the present buffer. And that allows us then to show the stuff we've just drawn onto the screen. The next part is dealing with touches. So again, if somebody touches EAGL view, which is the top parent view here of everything that's going on, we want to know they've touched the view. So what I do is there are three possible, well there's actually more than three, there's four actually, but there are three that I'm interested in at the moment, and we should probably catch the fourth as well. The three that I'm interested in is touches began, which means that a user has just touched the screen for the first time. Touches moved, which means that having recognized that the user has touched the screen, their finger hasn't been lifted off and they're now moving their finger. And touches ended means that it's now registered the fact that they've actually lifted their finger off the screen. Okay, so that's how you register touches on there, and information is provided to you about that registration. So what you do is you're giving a set of touches. Okay, so that means that if there's multiple touches going on, touches began, touches moved, and touches ended has actually got a list of all the touch events. So you'll be able to loop through. So say if somebody put 3 fingers on the screen, you'd be able to go through that collection or that set and look at the 3 touch events that were generated. Okay, because it will hold information about all 3. One thing that is interesting to point out at this stage is that every touch event has a unique hash value which is accessible inside the touch object. And what that means is that even though touches could be in different orders inside that set each time you query or each time the information is sent through, if you want to say track one of those 3 finger touches specifically, you could identify the touch you're interested in and grab its hash value. Once you've grabbed its hash value, you can then check to see the next time round, as you loop through those touches in the NS set, you can then say, well, the only one that I'm interested in at the moment is one that has the hash that it had last time. So that you know that that's the same finger, even though it's in a different order inside that set. And then, so that hash, when you touch and you move, all the way up to when you end a touch, it has that same hash reference, regardless of where it is inside the NS set. And that's really handy if you're tracking certain touch events. And it took me a while to track that down. It's in the documentation, but it's just like a one-liner that's a little bit cryptic. So it took a while to find out that that is available for us to be able to use. So inside these events, I don't want EAGL to actually do anything. I want to pass it on to be handled by whatever the game scene is that's running. So again, I ask the game controller to handle touches began. So all I do is I pass across the touches set, and I pass across the event, and I pass across a reference to this view to the game controller, and it will then marshal that to whichever game scene that I'm running at the moment, and it does the same for all of them. There is one in here which I haven't got, which is touches cancelled, which means that you sort of went to touch and you didn't, and so you've sort of cancelled the touch event, if you like. That could be handled in exactly the same way. The rest of this class is exactly as you see. I mean, it's just what we had before. So it's quite small now. It's really just setting up the view. It's controlling the game loop. And again, even the game loop we could remove from in here and put inside game controller if we wanted to, but for the moment I like it in here. It's simple enough to keep it in here. And then the drawing the view is very straightforward as well. So that's EAGL view, and so what we can do is we can jump in and have a look inside OGL game controller now to see what that's doing. So if we have a look in the header for the OGL game controller, you'll see that I'm importing a whole bunch of stuff in here. And all of these things like director, resource manager, sound manager, image, sprite sheet, abstract scene, these are things that are going to be used throughout the code. So importing them now, it just sort of keeps it together. I don't have to import them elsewhere. It's worth mentioning at this point, this little one here, this little import here, accelerometer simulation. This was a cracking find on the internet in Google Code, where I was really frustrated that I couldn't use the simulator and actually put simulated accelerometer data into the simulator. I had to keep running it on the device, which when you're just prototyping something and trying to get something to work, waiting for it to install and do all the bits it needs to do can be a real pain. So I wanted a way of being able to just say, well, as I move my iPhone, I want that data to be fed into the simulator, and that's exactly what accelerometer simulation does. There is a website for it, and I'll put a link into the blog that's obviously accompanying this video. I'll just quickly show you inside Google here. We've got accelerator simulator. So it's inside Google Code. Okay, and here you'll see all the information about it, and it gives you all of the instructions about how to embed it in your application, how you can use it, all of that kind of stuff. And it really is very, very simple. There are two parts. There is one part which is what you put into your application that you want to receive the simulated or you want to receive the accelerometer data. And the other part is actually the source code which creates a little application that runs on your device. So that when you're running this application here, it's this application which is sending the accelerometer data back into your application running on the sim. Really handy bit of code, extremely simple to use. And I definitely, if you're using the accelerometer, I definitely suggest you go and grab a copy of that and support the development, because it's a handy bit of kit. So what I've done is I've got a little group up here called AxSim, and you can see I've just got the two files that I need to import. I don't look at them, I don't touch them. All I do is I just import where I want to use the accelerometer data. I just import that. That's all I need. No other code is required whatsoever. Okay, so when you run it on the device, it will recognize it's on the device and the accelerometer will be used from the device. When you run it on the simulator, it will recognize it's on the simulator and it will just look for data coming from your device if it's available. And if it is, it will just react as normal. So I love the fact it's just that simple. There's no other effort to be required. So if we carry on going down, you'll see that I've got something called an abstract scene here. Which is just, as we'll see in a minute, this is just an abstract class which holds the core scene information about what do I mean by a scene. And a scene is just a container of code really that is responsible for doing a specific thing. So I've got a game scene. That's responsible for rendering the game, the logic for the game, and the actual core game itself. I've got a main menu scene. That's responsible for rendering the menu, handling the touches and dealing with people selecting menu items. So it just lets you break your game up into different scenes, and then you can start to do things like transitioning between them. So that's what abstract scene is, and I'm obviously going to be reading in menu scene and game scene because they are things I'm going to be creating instances of in a moment. Again, this is one of the classes where I can actually move these imports into the .m file and use forward declarations using @class. I've just not got around to that yet. Now, because we are saying that we are delegating all of our accelerometer information from the EAGL view class into here, we have to make sure that the accelerometer delegate protocol is actually as part of the header here, as part of the interface. Okay, so this is a UI view that I'm extending, but I'm just making sure that it can handle the accelerometer delegate functions as well. If you don't do that, you'll get complaints in the compiler. I haven't got very many things defined up here. I've just got whether GL is initialized or not, which is what was in the projects before, what the screen bounds are. I've got a very simple array here, which is holding the acceleration value for the accelerometer. And because the accelerometer produces 3 values, X, Y, and Z, then I need 3 locations to store that in. I'm then grabbing a reference, or I'm going to be able to grab a reference to the director and to the resource manager and to the sound manager as well. I've then got a number of functions here, methods. I've got init, which is, as you would expect, that initializes the class. I've got init OpenGL, which is actually a private class in here, but I've got it exposed as public at the moment, just because of the testing I'm doing. I've got render scene, which is called from our EAGL view. I've got update scene, which again is called from our EAGL view, and I've also got the 3 methods which are being called and used to pass on our touch events. So the touch events are being passed into these methods, and these methods will then marshal those events out to whichever game scene or abstract scene is currently running at that time. So pretty straightforward stuff on that. Inside the actual .m file itself, again, when I actually do the initialize, you'll see here that I'm just grabbing a reference to my director, resource and sound manager because they're singleton classes. I'm then initializing OpenGL, and there's no surprises there. That's doing the same initialization that I was doing inside my EAGL view, except this time it's now just been pulled out and put into this method, into this class. I'm then creating an array, or an NS dictionary actually, which is storing the game scenes that I've got configured. So if we have a look up here inside this group called game scene, you'll see I've got my abstract scene class, which we're going to be using, but I've also got my menu scene, my game scene and my settings scene. They're the 3 scenes that I've got at the moment. So because I want to use those inside my game controller, I'm creating instances of those just here of type abstract scene. Okay, I'm using the abstract scene because they all inherit from it, so I can say that's the type that I'm going to be storing inside my dictionary, and I give each of them a key. So simplest thing is I've got a key called menu, a key called game and a key called settings. So that just runs through and it allows us to have a dictionary full of all of the game scenes that we're currently running, so that I can then call them later on and move between them as necessary. I then just say that the GL initialized is false, it's not initialized at the moment. And what I do is I ask the director, okay, to set the current scene to menu. So I've got set current scene to scene with key, bit of a mouthful, but it says what it does. And I'm saying, so menu is the first scene that I want to render, okay? And also inside director against the current scene. So this is something that director has. You can query it and say, what's the current scene? What is the scene that we're meant to be dealing with at the moment? So I've said to the director, give me the current scene back, and I'm going to set the scene state for that scene to be transition in. Okay, so I'm setting this here to be the scene that I'm interested in, called menu. And once I've done that, for that scene, I'm telling it that I'm going to be transitioning in by setting its scene state. Okay, I hope that makes sense. So what we'll do is we'll take a quick look inside Director, so we see what that's doing. So inside Director here, I've got a few things. I've got currently bound texture, which we're using in the image class to say which texture is currently bound. I've got current game state, which is something we use to store the game state. I've got current scene, which as you would expect is the current scene. I've then got a dictionary of scenes in here, okay, which we could put the scenes in. I've got something called global alpha, and I'm using that to be able to fade an entire scene up and an entire scene down. So I've altered the image class, in fact, and the tile map class, so that the alpha of the color filter that's attached to them is multiplied by this global alpha inside the director. So if I quickly show you inside the graphics engine, the image class, okay, and we go down to the rendering, which is, let's have a look, just up here, here we go. You'll see that I'm setting the GL color, and for the alpha, I'm multiplying it by the director's global alpha. And it means that by changing just the alpha inside director, it changes the alpha of everything that I'm rendering to the screen. And that allows me to do the fade in, and that allows me to do the fade out. So just a very quick way of being able to control the alpha of an entire scene, even though some things are tile map, some things are image. This change here, and in the tile map, which is the same thing, just allows me to make use of that global alpha value. So going back to our, going back to our director, We've then got frames per second, which I said earlier is where we're storing our frames per second. And then we've got a number of methods here. So we've got add scene with key, which is we add a scene with a key. So if you remember inside our game controller, okay, here, inside the director, I'm saying add a scene with this key, and the scene is this, which I've just created up here. So the director is responsible for holding that list of scenes that we're going to be able to switch between. So in director itself, we obviously want to be able to say add that scene, which is fairly straightforward. We also want to be able to say set current scene to scene with key. So if we want to move from one scene to the next, we can call that command, and what it does is it changes the current scene inside director to the scene that we're passing in, as long as it exists. And then transition to scene with key, we'll see inside, that allows us to do a transition. It sets the scene state to something that we can use so that we can fade in and fade out. So I'll go into the director itself here. We're using the singleton macro again to turn it into a singleton class. Initialize is very simple. We create our mutable dictionary and initialize it. We say that the current scene is empty because there isn't one at the moment. We set global alpha to be 1 because we want it full intensity, and that's it. When we ask it to add a scene, again really straightforward, we just add to that mutable dictionary the abstract scene object using the key that's been sent in. When we say set current scene to scene with key, we do a quick check first. We say, well, the scene key that's being passed in, does it exist? Is there actually a scene with that name? If there isn't, we can't switch to it. So report an error and return no. So in other words, as a fail. If it does exist, then set the current scene to be the scene we found inside our dictionary. Set the current scene's alpha to be 0. Okay, and I'm doing this because I want the scene to be invisible to start off with. Okay, and then I want it to fade up. And then I'm saying here, I'm going to set the scene state to scene state transition in. And I've got a number of different states, which if we have a look, I'm defining inside my common .h file. So you'll see here I've got some scene states. Okay, I've got one called idle, transition in, transition out, running and paused. They're just nice words because they're its enumerator rather than just using numbers. So it's just simple to know what's going on. And that's it. So the director is really straightforward. It's just holding a list of these scene objects and allowing us to move from one scene to the next. That's it. And later on, if we wanted to store anything else that was shared across all the different scenes, the director is probably the right place to hold that information. Okay, so back down to our game side of things. What I'll do next is we'll have a look at the abstract scene. So remember, we can have an array inside the director object. We can have an array or a dictionary of all the different scenes that we have inside our game. And all of those scenes are children or inherit from the abstract scene. So we'll have a look at that and see what it does. Again, we import things that are going to be important for this and bring them in, like director animation, tile map and so on, because they're the things we're going to use inside our game. I then set up a few things that we need to be able to reference. So I need to be able to reference the director, I need to be able to reference the resource manager and the sound manager. And then we're going to have things like the screen bounds, the scene state, scene alpha, what the next scene is going to be, and the scene fade speed, because I'm going to fade these scenes in and out. So they're the things that every single scene will need to have. Inside the actual implementations of the scenes, you can have many more things to there for the specific scene functionality. But by default, they're all of the things that a scene should have, which is why they're inside the abstract scene class themselves. We then have a couple of properties, so we want to be able to update and read the scene state, and we want to be able to update and read the scene alpha. Now also in here, we want to be able to update, so the director is going to, or the game controller along with the director is going to feed us an update request if we're meant to be updating, so we need to be able to handle that. We also need to be able to handle the touch events. So what I've done is I've created my own methods here called update with touch location began, moved and ended, and it feeds in all of the information that is normally created by a touch event into this class. So now you've got access to everything that touch event had inside your class to which that touch event is related. Okay, because remember, the director and the OGL game controller, they will direct those touch events to whatever the current scene is. So the running scene will only get events that it should see. Okay, it won't get anything that it's not responsible for. I've then got the same thing for accelerometer. We can update the accelerometer data inside here from what's sent through to our game controller. And we've got something called transition to scene with key, so that you can ask this scene to transition to another scene, and it does a small piece of functionality around that. And lastly, we need to say to the scene, render yourself, so that it can actually render. So that's the abstract scene header, and inside the M we've got nothing but placeholders. So if you wanted something in here that always happened, you could put that code inside one of these methods. And as long as you then called super inside a game scene, so for example you called super and whatever the name of the method was, then you're actually running this method first, followed by whatever code you're putting into it. Okay? But for the moment these are all empty, because all the code that I'm going to need is going to be code that's actually inside my instances of abstract scene. Okay, I hope that's making sense. I mean, what would probably have been a good idea was to have some kind of class diagram. But again, even they can be a little bit confusing sometimes, and you can create them inside here. So again, what you can do is inside your design, you can create a class model, which is grayed out for me at the moment. But you can do a quick model, which allows you to then let's have a look, see if that won't. Yeah, there we go. If you wanted to, you could create a quick model, and what that does is it draws a nice class diagram for you, showing you what objects are doing what. Okay, so we can see here that I did it for just that object that I was on, which was the image object. Okay, and you can have a look in here and you can identify what the properties are and so on. If I close that, if I was to actually click on tutorial and ask for a quick model, I would get everything inside here. Okay, so we can see there's my NS object, because the NS object really pretty much everything is inherited from. And then see here, you'll see that abstract scene is being used by my setting scene, my game scene, my menu scene. They're all being linked into it. You can see the game controller is actually a subclass of UI view, as is the EAGL view, and you'll see that it's using the accelerometer protocol. So it's quite nice to be able to look at these diagrams and see what things are inheriting from what, and it's sometimes an easier way of seeing what's happening. So anyway, that's something you could have a look at if you wanted to. Okay, so inside, we've had a look inside our abstract scene, so what I'll do is we'll have a look inside our main menu scene, okay, and we'll have a look and see what's going on inside that. So in here, what we have is just the code that is necessary for dealing with our main menu. So you can see that we're actually inheriting from our abstract scene, so everything inside our abstract scene is now available to this class, just as if you're inheriting from UI view or any of the other foundation classes or Cocoa classes, you will know that you get access to everything they have if you actually inherit from them. And what I'm doing is I'm saying inside my menu class here, I'm going to have an array of entities, menu items. I'm going to have a background that is going to be rendered, and I'm also going to have this thing called an origin. And that's it. It's pretty straightforward stuff. Inside my menu scene, it's a little bit more complex. When I initialize it, I grab hold of instances to shared, resource, and sound manager. And again, these are identified and defined inside our abstract scene. All I'm doing is actually populating them with instances or references to these objects. I set my fade speed, I set my initial scene alpha, which is 0. I set my origin for my scene here, which is, I'm just setting it to 0, 0. And I tell my shared director that I want the global alpha to be whatever my scene alpha is. So I'm just linking those two things together. I then go and create an array of menu entities and allocate and initialize it. I create an image, which is of my background, okay? And I then set the scene state to be transition in. So I'm going to say, because I'm initializing it, the first thing the scene will do is it will transition in, and that means in my code I'm going to be fading it in, okay? The next scene is nil, we don't know what the next scene is going to be yet, and we then go to initialize the menu items. So inside the initialized menu items, what I've got here is And I've broken this down to be a bit more object oriented in this way. There's probably other ways of doing this, but this just sort of kept things simple. What I do is I go and create instances of an object called menu control, which we'll have a look at later. And when I create my menu control, I pass it an image, which is going to be used to print on the screen. I tell it a location of where I want it to print on the screen. I tell it that I want to render that image with the center, so that point is the center of the image I want rendered. And I give it a control type. So the reason for that is that when somebody clicks on that menu item, I want to know, well, based on the menu item you've clicked on, what do I do? What have you selected? Is it a new game? Is it settings? Is it high scores? So I just use an enumerated value to do that. I then add this item to add my array of entities and release it. And I do the same thing for new game, settings, high scores and quick game. If we have a look inside game resources and images, you will see that I've got, if I look at new game, okay, you can see there's my new game image. If I look at settings, there's my settings image. If I look at, let's have a look, high score. Okay, so they're the images that I'm going to render, and all I'm doing is I'm passing those images into my menu scene here, and into this thing called a menu control. So we'll look and see what menu control does now. And if I pop up here into entities, this is another group that I've got. I've got two groups inside entities. One is actors, which we'll look at later, which is about creating baddies on the screen. The other one is a controls one, where I was trying to sort of come up with an abstract control where I could, anytime I wanted to have a control on the screen that you touched and it went and did something, you could use this. I'm not completely happy with it yet, but I'm sharing it as it is and you can have a play around with it. But basically every control has a set of, and again there's an abstract version here obviously, so every control has access to director, it has an image, location, a state, what type is it, a scale and an alpha. Okay, so I just set my header up to do that as you would expect. And I have the ability to say update with location, update with delta and render. Update with location is important because I want to be able to say, here's a touch event, here's the location I've received from a touch event, does that touch event location exist within the bounds of this menu option? So that's how I'm tracking when I touch the screen, does that position that I've touched the screen on actually exist inside one of my menu options? So each menu option is responsible for taking a location and checking to see whether it's inside its bounds. Inside.m, I've got nothing in here again, they're just placeholders or stubs. So when I actually do create my menu control, again you'll see I've got nothing in the header I'm describing because everything I need is already in abstract control. And I'm just defining again the entities, or sorry, the methods that I'm going to be using inside this class. If we look inside the .m file itself, you'll see that when I initialize it, this is very similar to what we've done before. I'm saying that I'm grabbing hold of the shared director, I'm creating a brand new image instance here. Okay, now I'm actually casting this to image, as you can see here. And the reason for that is init with image is actually an initializer for the UI image class as well. And so the compiler gets a bit confused and doesn't know which class you're specifying that it should be used. Even though I'm saying image here, it's not. It does get confused. And it thinks, so is that UI image? Is that your image? What is it? So by casting it to image, it knows that I'm actually calling the init with image inside my class, not inside UI image. That was a bit of a funky one that came up that I had to sort out. I'm setting the location, whether it's centered, the type, the control. So at the moment the state is idle, it means it's not doing anything. And I set its current state and its current alpha. Okay. The next thing I'm looking at is the update with location. So we get this touch location, and what I've found is there's a nice way of being able to send things around a string. So sometimes you need to be able to hold an object, and things like CG point aren't objects, they're just structures. So if you want to actually say put a CG point into a simple structure, you can turn it into a string. And there are some really nice little commands. So there are things like make string from CG point and stuff like that. So you can actually say, here's a CG point, turn it into a string for me, an NS string. You can then flip it around the other way. So I'm doing that when I pass this information over. I'm sending it over as a as a CG point encoded as a string, and inside this method here I'm actually using the command CG point from string, and it goes and creates a CG point from the string that I pass in. Okay. So what I do inside this class is I create a rectangle, and the rectangle defines the bounds of my control. And to do that, all I'm doing is I'm taking the image that has been defined and I'm getting its width and its scale, okay, because as it scales up, if you scaled it up or scaled it down, the size of its bounding box is going to be changed as well. And I just do a little bit of maths here that makes a rectangle. So I say where it starts, and now I divide, it's minus, sorry, let me give a little, the x location, because I'm rendering in the center of the image, the x location of the bounding box has to actually be less than the location where the rendering happens. So what I do is I'm saying, well, if I'm rendering in the center of the image, I need to just take the image width, divide it by 2, and that's where my x location is. So I do that for x, I do that for y, and then I do the same for the width and the height, and there I have my bounding box. I turn my string encoded location back into a CG point, and then I just simply use the rectangle contains point command and make sure that we're not scaling. So as long as the state isn't already scaling, and as long as the point that I've got is inside the bounds of my control, I know the user has tapped my menu option. So then I set the state for this control to say control scaling, which means because what I want to do is when somebody taps my menu option, it scales. It just starts to scale up, and I'm also going to have it fade out as well. Inside the update with delta, which will be called from within inside my game loop, okay, so this is like the updating logic, I'm going to basically be, again, because I'm passing numbers around and I'm passing them around as objects, I pass the delta in here as an NS number. So I convert the NS number back into a GL float, okay, using the float value method. And I then do a quick check, and I say, well, if the control is scaling, then I'm going to call this method called scale image and give it delta because I'm scaling the image up. If the state is actually idle, then just set the scale to 1 and the alpha to 1. Okay, so don't be doing anything with it. Scaling is really straightforward. All I'm doing is saying add to the scale whatever my scale delta is, and I've defined that at the top here. Okay, you can see that just there, and you can tweak those to get different effects, speeds. And so I'm just increasing scale by that, and I'm increasing alpha by, decreasing alpha by that. So as it scales up, the alpha is decreasing. And I keep doing that until we hit max scale. And once we hit max scale, I then change the control state to selected, meaning I've finished doing my rendering and I've finished doing my little bit of UI work, which means that you saw it scale up and fade out. Now the control has been selected. Okay, and it's on selection of the control that the rest of the code will be able to say, that control has been selected, I'm going to act upon it. And for rendering, as you can see, really straightforward. For the image, I set the alpha. For the scale, I set the scale, and then I go and render at the point that has been defined in the center of for the center of the image that was given to this control. So I hope that makes sense. That's my control thing. So I'm basically building out here the ability to have any control, and the control will be able to have an image that represents it, a location. It will be able to identify whether it's been tapped based on a location, and it'll be able to tell you when it's been selected. Okay, so they're the key things that I really want in one of my own game controls. Okay, so going back to our menu scene here, what we do is when we're actually doing our update, as long as the scene is running, okay, which we do define it to be running, once it's finished doing the transition in, then we start processing, and I'll go through the processing in a minute. If we're transitioning out, this is what it wants to do. If we're transitioning in, which is what the state is initially, then all I do is I just keep adding to the scene alpha whatever our fade speed is times by 0.02f, okay, which just gives me a constant speed. Now, there is a reason for this. You're saying, why aren't you using delta? And I came across a really weird bug, and I haven't got to the bottom of it yet, but because I'm loading a fairly large tile map, it's 100 by 100 tiles, which is 10,000 tiles in all, and it has 2 layers, so 20,000 tiles. It takes about 4 or 5 seconds on the iPhone to load up. And what I was finding is that for some reason my game states were starting to render after the game was loaded, and even after the tile map was actually loaded, the game state was starting to render, but for some reason there was a big pause between the first render. So delta that was being passed in was enormous. Okay, the first delta that was passed in was so big that when you added it to the fade speed, you were already over 1. So there was no fading, it just meant that the scene immediately appeared. Don't know why it was doing that, because there's nothing, there's no code in the rendering scene to do with loading anything or any such thing like that, but it just was, giving you a big delta on that first one, as if it was finishing off what was going on previously, and then that would screw up the fading. So what I've done is I've hard-coded a delta value for the fade-in, so no matter even if there is a big delay for that first render, it will fade everything in properly and you won't get that sudden appearance which I was suffering from. So all I do is I update my scene alpha using the scene speed times this sort of hard-coded delta value. I then set the scene alpha to be, the global alpha inside director to be the scene alpha, and remember everything that's rendered inside image and inside tile map uses that global alpha, which means that automatically that means that I'm fading the whole image and everything that's rendered on screen. And then all I do is I say, well, as soon as the alpha reaches 1, it means it's fully visible, change the game state to running. Okay, so in other words, stop doing the transition in and set the state to running. When it's done that, it will then, in an update loop, start running this piece of code here. And what this piece of code is doing is it's saying, run through every single entity inside menu entities. Okay, so it's saying, I want you to go through every single control that's inside menu entities and run the update with delta selector. Now, you can pass information in this kind of command. You could do a for statement, which means that you could actually just then say, if you said that A equals or object equals your menu object that's inside menu entities, you can then say menu object menu object update with delta and pass the delta in. I've just literally, because it's not quite handy to have this one command that loops through all of the entities, I'm using that. And you'll also see that's why where I do my update, I'm using an NS number. You can pass an object into this method that you're calling, but it has to be an object. You can't pass in either a native number or a structure. So I'm turning my float delta value into an NS number, and then I can feed it across. And that's why NS number is being used inside my update routine. Once I've done that, I then loop through each of the controls, or the menu controls, inside my menu entities, and I have a look to see if any of them have got a controlled state, have got a state of control selected. If they have, I set that control to say idle, and I set the state to be transition out, because now it means that you've selected the menu option and I want the menu scene to transition out now and move over to whatever the option is that you've selected. So after setting the transition out state, I then do a quick check and say, what type of control was it? Was it a new game control? Was it a settings control? And that allows me then to know which game scene or which scene I need to transition to. So at that point, I check my enum, and if it's game, then I tell it that the next scene is going to be called game. And that's the key of that scene inside my director, inside the mutable dictionary we looked at earlier. If I've got the control type of settings, then I do the same thing, except I say it's the settings scene that I want to move to. Okay, so because we've set transition out, this part here isn't going to run anymore during an update. It's going to be this part that runs during the update. So again, I do the opposite of what I did in the transition in, is I start to fade out the alpha of the scene and pass that to the director. And as soon as the scene alpha is below 0, which means it's all gone, then I ask the director to set the current scene to the next scene key, which has been defined just up here. And once I've done that, I then set the scene state for the scene we're about to move into transition in. So that as that new scene starts to get rendered, it will be in the transition in state, so it will fade up. Okay? So that's what I'm doing. I'm hoping you followed that. I mean, it's a fairly clean structure, a fairly clean way of doing things. State inside a game is absolutely vital. Knowing what state your game is in means you can do these kinds of switch checks so that you're only running code that should be run based on the state of your game. And it does keep things fairly clean and fairly simple to then be able to walk through and to understand. If we go a bit further down, you'll see that when we set the scene state, if we're setting the scene state to be transition out, we make sure the alpha is full. If we set the scene state to be transition in, we make sure the alpha is 0. So it's just like a safety catch to make sure that we are setting the alphas correctly based on whether we're transitioning in or whether we're transitioning out. So the next part is how are we handling touches inside here. So you'll remember that we are passing from the game controller through to the scene, which is being identified by the director as the current scene, all of the touch events that are happening. And we're using the update with touch location began or moved or ended. If we've got a began, what we need to do is we need to basically grab a touch event out of that. Now at the moment I'm only interested in one touch event, so I just say go and grab a touch event out of that and I'm going to start reacting to it. Okay. So what that means is that I create an object of type UI touch, and my game event is going to be a touch event, which is why we're passing this through. And I basically say, go and get me the touches for a view. Remember, a view is the reference back to EAGL view, which was being fed through to us. And I'm after any object. If there's more than one, just give me any one. I don't really care what it is, just give me one of the objects. Once we've done that, we then need to turn that into a location. So we need to turn the touch event into a location on screen. And to do that, we've got the location in view method, which is available inside a UI touch class. So we can say that our CG point location, which we created, is equal to the location in view, and you tell it what view the location should be in for that particular touch event. Okay, so that's how we're saying whereabouts in the view has the user tapped the screen. That's how I'm grabbing it. That's how I'm getting hold of that location. Now, one thing that's a bit of a pain is that the coordinates that are used for returning a UI touch are different to the OpenGL coordinates. X is the same, 0 on the left and moving positive as you go to the right. It's the Y coordinate that is different. In OpenGL, the Y coordinate goes from 0 at the bottom to 480 at the top. In the UI view, it goes from 0 at the top to 480 at the bottom. So what we need to do is we need to switch that around. On the y-axis, we need to switch that around. So very quick way of doing that is say, well, just take the location value we've got away from 480, which is the height of the screen, and that will then just switch it around so that the y value is being registered correctly. And once I've done that, I then make use again of this make objects perform selector function, calling the menu items in turn. And remember, inside menu items, we've got instances of the menu control, and the menu control has got this method called update with location. So what I'm doing is I'm actually saying run that method and pass in an NS string. Okay, and the NS string I'm constructing from a CG point, and the CG point is the location that we've just calculated. So now, because I'm using make objects perform selector, now you can see why I'm wrapping the location in a string. Whether I'll keep it or not, I don't know. I really don't see it causing too many performance issues at the moment, but later on I may well switch that out for a normal for loop, meaning that I don't have to encode the location into a string and vice versa. I can just send the location straight over as necessary. And what I do is I do exactly the same for both the touches began and for the touches moved as well. I'm actually feeding the touches moved in. So if you were to hold your screen, if you were to hold your finger on the screen and move it across all of the menu options, it would, as your finger is sliding up, check each of the menu options you're moving over the top of. Probably not much use of it, but I was testing things out in the menu menu scene to see how things would work. I've then got my transition to scene with key, which is very simple. All that does is it tells the current scene, which is this one, to transition out, and sets the alpha to 1 so that you can go from 1 to 0 in the transition. And when I render my background, so it's in the middle of the screen, and I then again use the make objects perform selector, and I get all of my controls to perform the render. So I get all of them appearing on the screen. Woo! So I hope that makes sense. We've covered loads of stuff here, and you may have to watch this a few times to sort of follow through what I'm doing. But in essence, I have got my EAGL view, which is creating an instance of my OGL game controller. OGL game controller is then creating inside my director class a list of all the different scenes that are available in the game. It's then passing control, or whenever it gets asked to do a logic update, or whenever it asks to do a render update by EAGL view, the game controller knows what the current scene is from the director, and so asks that current scene to perform an update, to perform a render, or to perform a touch update, okay, using the touch events. The information necessary to do the update, to do the touch events, is passed from the game, from EAGL view into the game controller, and from the game controller into whatever scene is currently running, where the scene can then make use of that data inside the processing that you need. And that's basically it. That's the logic I've got to give me different scenes and to be able to transition in between them. Excuse me. So let me just run the project at the moment. Okay, let's just have a look at something, because we've looked at a lot of code for over an hour now. So let's just run the project and we'll see what that actually gives us. So I've got this loading screen here, and we'll quickly talk about how I did that later. And you'll see that disappears, and then we get my main menu appearing. Okay, and I've got my different objects here. Now, things like quit game don't do anything at the moment. So when you've gone through them, it will just it will transition out, but then come back again, because I've not set it up to actually do anything. Same for high scores. It will transition, the scene will try and transition out, but it will just come back to itself and transition in again, because there is no other scene to move to. Alright, so again, if I was to hold down the button and move across, it won't actually do anything, of course, because it needs to have a particular event on a particular menu control. But you can see that's what I've done, and I'm changing the amount that it's scaling as well. Okay, if I did that for settings, okay, let me just do settings. That will fade out and fade in a new scene, and the new scene has just got settings on there. Okay, and you'll see that it faded in because, again, I've made changes in the project so that the angle code font class makes use of that global alpha value in director. So as it's rendering, it multiplies the alpha value of its color filter by whatever is in the director. So it does give me a very simple way of fading in and fading out any scene that I've got. Now, at the moment, this is a bit of a flawed screen because there's no way of getting back to the main menu, which is a bit of a pain. So what I'll do is I'll stop that and just run it again back to the main menu. Okay, and then I'll hit new game, which will fade out the menu and fade in the actual game itself. There we go. And you can see that in this game I've actually got some baddies running around. There's no collision detection between the baddies and my player, but I've got these guys that have got some artificial intelligence. They will wander around, they will not walk through walls, they will bump into walls, and they will change their direction and speed at will. So they'll just wander about, they'll suddenly change direction, they'll suddenly change speed, etc. So that's just some of the AI that I've got implemented for these guys, which we'll run through. Okay. So, but there you go, that's the main screen. Again, no way of quitting out of here back to the main menu. That will be something that I will add. Excuse the noise, hopefully you can't hear the big motorbike going past. That'll be something that I add as I go on and actually run through some of the rest of the tutorial. Okay, so that really gives you an idea for how the game structure is being done. And the next thing that we're going to start to cover is we're going to have a look and see how do we actually do the game side of things. So that's the structure, that's how we get our fading between menus, between different game scenes. What I'm going to do next is I'm going to have a look at the actual game itself. I'm going to have a look and see, well, how have I coded the guy running around and doing the things that he does inside the game. So we'll now move on and have a look at that.